the end of the previous lecture, I posed a question of how did a $100 increase in investment cause a $400 increase in spending and income as we transition from point A to point E. And the idea behind that is something known as the multiplier effect, where spending generates even more spending. And the idea behind it is, suppose that I give you $100, you're going to take that $100, spend it at a particular shop. The owner of that shop is going to take that $100, maybe buy some materials from this particular shop, and then that owner is going to receive that particular money, spend it somewhere else, and that sort of effect just keeps on compounding as we go from individual A to B to C to D, all the way down. So here, your $100 increase in income has essentially started off the process of even more spending within the economy, and that is known as the multiplier effect. And this multiplier effect is very, very prominent in a lot of politics nowadays, especially with the universal basic income, or with one of the candidates sort of asking, what happens if we give you, say, $1,000 or $2,000 per month? This is the idea of the multiplier effect. So if I give you $1,000 or $2,000 per month, or if the government does so, it should generate even more spending within the economy due to this multiplier effect. So let's go ahead and take a look at the multiplier effect a little bit more in depth. So here, the multiplier effect. Multiplier effect. So $2,000 per month, that sounds like a really, really nice thing to have, right? So here the multiplier effect states that spending changes, and we'll talk about these spending changes just a little bit, alter equilibrium income by the spending change times the multiplier. By the spending change times the multiplier. So here the multiplier effect states that spending changes alter equilibrium income by the spending change times the multiplier. So here we need to find the multiplier, take that multiplier, multiply it by how much spending is going to change by, and that will tell us exactly how much equilibrium or aggregate income changes by. The key phrase that we're going to hone in on here are these spending changes. So how can we change spending within our economy? Well, it's going to be through our components of GDP. So spending changes through C, I, G, and then net exports, and X minus M. So these are the only components that are going to be affected by the spending multiplier. And that's something I'm going to keep on drilling into your head. If we change consumption, investment, government spending, or net exports, it is going to be affected by the spending multiplier. Nothing else will. So do be very careful of this fact. So if we change any one of these, if we increase it or decrease it, because the multiplier effect does work in both directions, it's going to alter equilibrium income by a greater amount. The multiplier equation can be given as such. So multiplier. So with this multiplier, we typically call it the spending multiplier. So here, just in general. So there are a lot of multipliers that we take a look at within economics. In this particular chapter, we consider this to be the spending multiplier. So here, the multiplier is going to be 1 over 1 minus the MPC. Simple as that. That is going to give us the multiplier. Whatever multiplier comes out to be, we take that number, multiply it by the change in spending, and that will tell us exactly how much aggregate or equilibrium income is going to change by. Remember that because there is a relationship between MPC and MPS, 1 minus MPC is also equal to MPS. So 1 over MPS will get the same value. Remember that MPC plus MPS has to equal to 1. So if you take 1, subtract out MPC, we'll get 1 over MPS. So remember, doesn't really matter what formula you use. There is always enough information for you guys to go ahead and calculate this out. So in the previous problem, we increased investment by $100, and we also noted that our sort of multiplier, our MPC value is equal to 0.75. So let's go ahead and write these numbers down. We notice that our MPC is equal to 0.75, and we increase investment by $100. So investment increased by $100. And we want to see exactly how much our equilibrium income is going to change by. First, we want to go ahead and find the multiplier first. We use the MPC value, 1 over 1 minus 0.75. We go ahead, simplify this as much as we can. It'll give us 1 over 0.25. Put this into your calculator, or you can do it off the top of your head. Our spending multiplier is equal to 4. So any spending change that we have is going to change our equilibrium income by 4 times that amount. Here, we increase investment by $100. First of all, is investment affected by the multiplier? Yes, it is. CIG net exports. If we change investment, it will be affected by the multiplier. Here, investment increased by $100, so this is a positive $100. We want to be sure to make sure that we have our signs correct because it will work in both directions, as we're going to see. We take this spending change, we multiply it by our spending multiplier times 4. So that tells us that we're going to have a positive $400 change to equilibrium income. And that's exactly what we saw as we transitioned from point A to point E. When we increase investment by $100, we notice that at the end, as we transition to our new equilibrium, we notice that aggregate expenditures and our income all changed by $400 from $4,000 to $4,400. So here, this is all due to the impact of the spending multiplier. So here, a few more things we want to note about the multiplier effect. It occurs when an initial amount of spending causes income to grow by a larger amount based on the multiplier. It's calculated as we've seen here, 1 over 1 minus MPC, or 1 over MPS for short. And the greater the MPC, the higher the spending multiplier is going to be, because the number is in the denominator right here, so the higher the MPC, that means it's the smaller the denominator is going to be, and the smaller the denominator, the bigger the entire fraction does become. So if we are a more consumer-based economy, like we are here in the United States, we have a very high MPC. That just tells us that the spending multiplier is going to be extraordinarily high as well, compared to say like a country like in Japan. Japan is known as a nation of savers, so the MPC value is going to be seen as relatively small, which just tells us that, hey, the spending multiplier isn't going to be as big. So this was a big idea behind the sort of universal basic income, where if we have a very high MPC, that income that we give to these people is just going to continue to be spent within the economy and keep on spent and spent and spent, and that will eventually lead to increased aggregate income for the entire economy. But of course, remember, the MPC values do differ from person to person, so that can lead to sort of a dampening impact in terms of the spending multiplier itself. Here, we just keep the MPC constant for everybody within the entire nation, just for simplistic reasons, to make our predictions and analysis a lot more easier to sort of interpret. So here, we do want to get a little bit of realism with that as well. So one thing that we can also do with this MPC is also build up an example to see exactly what happens to consumption, income, and savings. And this is where we're going to take a look at this particular example right here, where I increase investment by $100, but we're now going to use a different MPC, so 0.8 in this instance. So here, this information here, I'm going to go ahead and put down on the notes in order to see the transitions and to ask this particular question. So here, MPC equals to 0.80, and start off the question. Suppose that there is a $100 increase. Suppose there is a $100 increase in investment. And the question that we want to ask is, what is the change in equilibrium income? What is the change in consumption? And then what is the change in savings? So 3 things that we can actually ask based on this particular setup that we have right here. Suppose there is a $100 increase in investment. What is the change in equilibrium income? What is the change in consumption? And what is the change in savings? So here, remember that change means that we need to take some type of difference. So that's going to come in a little bit into play with all this. So here, remember, when we need to calculate the consumption and savings, the change in consumption, change in savings, that's where MPC and MPS are going to come into play. But before we get started with all of that, what will be the very first step in order for us to ask this question? Well, we want to go ahead and see what the multiplier is. So multiplier, once again, 1 over 1 minus MPC. Our MPC is 0.8 this time. And when we solve this out, our multiplier is equal to 5. So any new spending change that we have is going to get multiplied 5 times that amount. So what is the change in our income going to be? Remember, change in income. Change in income. So change in income, delta y, we can go ahead and take a look at what we are changing. Is investment affected by the multiplier? And of course it is. CIG net exports. So yes, when we change investment spending, it will be affected by the multiplier. So the change in income is simply going to be the change in spending, which is $100 in investment. We multiply it by our multiplier, which is 5 in this instance. We bring that straight down. So therefore, our change in income is a positive $500. So equilibrium income within the economy changes by $500 when we increase investment by $100. But out of this $500 right here, how are you and I, how are individuals within the country going to divide this $500 up into consumption and to savings? That's where MPC and MPS come into play. MPC, remember, is change in C over change in Y, while MPS is equal to change in S over change in Y. Remember from all of this, these are going to be connected to one another because MPC plus MPS equals to 1. So what exactly are we trying to solve for in these equations right here? Do we have an MPC? Yeah, we do. It's given to you first off in the problem right here, 0.80. So here, substitute that number in, 0.80. Do we have a change in consumption? No, that's exactly what we're trying to solve for. So what is the change in our consumption once this happens? And then finally, change in income. We just solved that out. That was the positive $500 that we see right here, positive 500. So all we need to do in order to solve for our unknown, our change in C, just multiply these two numbers together. And this is going to be the same methodology that we went through in a few of the previous videos. So remember, this equation was given to you, but we can algebraically manipulate it in order to solve for our missing unknown. So when we take 0.8 multiplied by 500, our change in C is equal to $400. So when our income changes by $500, our change in consumption is going to be $400. And then for our change in savings, we know that MPS has to equal to 0.20 because MPC plus MPS equals to 1. Even though I don't explicitly give you MPS, based on the relationships, you can find it. We want to find out what the change in S is, so that's our unknown. And the change in income is equal to 500. The denominator still stays the same. Once again, multiply it through in order to solve for change in S. Change in S is equal to $100. And you're going to notice that, hey, the change in S plus the change in savings has to equal the change in income. That was true in our previous video as well with our previous example. So with all of this, there are a lot of relationships that do develop. And this is essentially the multiplier effect into an application. If we increase investment by $100, it could be consumption, government spending, or net exports, as we're going to see. When we increase any spending component by $100, we notice that it's going to be affected by the multiplier. That has a huge impact in the aggregate income or equilibrium income, and that can once again have an impact on our own consumption and savings habits as well. So with all of this, we do notice this multiplier effect. Everything that's sort of listed right here is what we just sort of just wrote down. The total potential effect on income equals the initial change in spending times the multiplier. And as we continue to keep on increasing any one of these spending components, suppose that we go ahead and increase investment by another $100. Once again, it's still going to be affected by the multiplier. And in this example, remember that our MPC was equal to 0.75, so the multiplier was equal to 4. So before, we started off with $4,000 in income, but then we added in $100 of investment, and then bam, we noticed that at point E, our equilibrium income increased by $400. So $100 of spending change times the multiplier. That's our new equilibrium income. If we increase investment by another $100, so we go to $200 now, as we go from point E to point B, we notice that, hey, it is still affected by the multiplier. So a $100 change in investment multiplied by 4, our multiplier. So now we go from $4,400 to $4,800. So here, investment is affected by the multiplier. Any change in its and any change in investment will be affected by the multiplier. Take the investment change, multiply it by the multiplier, and you know exactly what happens to our new equilibrium income. And we're going to go ahead and see how this is going to come to play with our other components of aggregate expenditures. How does government spending come into play? How do imports, how do exports come into play? And we're going to see that because they are all considered to be spending components, they will be affected by the multiplier, and will continue down a very similar process with the graphical approach that we see right here. So we'll go ahead and see how that all comes to play, and we're going to also take a few notes about the multiplier effect itself. What happens if we move in the opposite direction as well? So remember that the multiplier effect does work in both directions. Here, when we increase spending, we notice that income should increase as well. But what happens if we actually decrease spending by $100? Then it will be affected by the multiplier as well. So what happens if we started off with $200 of investment, but decreased investment by $100? We're going to notice that equilibrium income falls by $100 times the multiplier, so by something greater than the spending change. So this is why some recessions can actually turn into depressions, and why some recessions can feel a lot worse than previous ones. We'll take a look at that and the paradox of thrift in the next few lectures.